any last piece, slice of pizza? Okay. Last thing is over. Wake up, wake up. It's that.
It's here.
Here we go.
All right, it's working.
Yes.
If you want pizza while I'm talking, feel free. Feel free to go wherever you want to do whatever. Well, look at that. Why is it doing that? All right. So, hi everyone. I'm Doug. It's been nice chatting with you while we ate pizza. Oh, do you want to?
Can you hear him? In the
Yeah,
back? Otherwise, you can also have microphones.
If you can't hear me, let me know. I'll pick up a mic. Otherwise, I'm pretty loud. My name's Doug Sillers. I've been doing Android stuff for a number of years, looking mostly at performance and how to speed up Android applications, iOS applications, and then web. So this talk has a little bit of web in there too. I hope you guys don't mind, but a lot of the same things that you do to improve Android performance, it's pretty much exactly the same for web, and some of those stories are a little bit more fun. So I'm going to talk a little bit about that. I'm going to talk a little bit about video, because video is becoming central to so many applications and websites as well. So how we can optimize delivery of video so that it works really, really well. But we'll start off with a question, and this is up in the Alps. How many of you sort of get a hit in your stomach when you think about walking out on that walkway out in the middle of the mountains, knowing that it's several hundred feet down? And you get a little freaked out, right? So a couple of years ago, Ericsson did an experiment where they put sensors on people's heads to measure stress levels of different things. And they discovered that standing in line, like at the market, is very stressful to people. And they found that standing at the edge of a virtual cliff is very stressful to people. But they found that experiencing a slow mobile app is actually more stressful than standing on the edge of a cliff. And so what this means, of course, is if your app is slow or if your website is slow, that feeling you get when you think about how scared of heights you are, that's what our customers feel every single time an app is slow. I'll put these slides up too if you want to steal them from the web later. And that's, of course, the reference down to the stress of streaming delays. But how much do people hate delays? Google found 53% of people abandon mobile websites after a click. This is ad click data from like DoubleClick, right? So there's an ad, you click it. If it's 3 seconds, people stop going. Another study showed that people get more frustrated and are less engaged. Obviously, if they're frustrated and not engaged, they're less likely to buy stuff if you have an e-commerce site, so you don't want to do that. Or they're less likely to come back, right? If it's a frustrating experience, people stop using your application. Amazon and Walmart found that slower sites actually decrease their revenue because people can't click as many pages. You know, I'm going to spend 5 minutes on Amazon or 5 minutes on Walmart. And then, of course, 4% of mobile users admit to throwing their phone when something is slow or frustrating to them. And so, you know, you see someone with a cracked screen, it might be because that website or that app was just a little bit too slow. But as networks get faster and phones get bigger, people are demanding these rich and immersive experiences, but they also want them to be fast. So how do you deliver these rich, immersive experiences that are also fast? It can be a tough thing to do. So let's look at some of the things we can do. This is a screenshot from the tool that I helped build when I was at AT&T. And the problem is cellular is really high latency. And what that means is sometimes it just takes a long time for the phone to connect to a tower to establish a connection that will actually transmit TCP/IP, HTTP data back and forth. On 3G, it can take up to 2.5 seconds for that connection to be established. It's about 250 milliseconds on 4G. And then, of course, the round trip time, every single packet going back and forth between the server and the phone can take between 100 milliseconds on 4G to 200 milliseconds on 3G, which leads to delays. It makes things longer to deliver. It takes longer for things to be delivered. But in our tool, These are the packets coming back and forth. So we're measuring the packets that are being sent over the network. And because there's this startup latency, the network keeps the radio on after that last packet for like another 8 to 10 seconds. Because to try to avoid that startup, to avoid those delays. And so there's this balancing act. How long does the network want to leave the radio on? Because if you leave the radio on, the battery dies faster, right? Nobody likes a dead battery. But if you turn it off too quickly, you're going to get these connection delays, which makes apps and websites appear slow. So they're always trying to tweak that thing, those parameters. Well, what's important to say is that there is this long time frame afterwards. So if your app is making a connection every 5 or 10 seconds, the radio is never turning off in the background. And so your app is actually using the same amount of battery draining because the radio never turns off as streaming a movie, right? When you watch Netflix, you expect that the radio is going to be on and the battery is going to drain really quickly. But you can also do the same thing with just a very simple app if you don't turn off the radio when you're making network calls. So what I'm going to talk about is some tools to test your app or your website. We're going to look at some of the best practices to speed up the content delivery and look at some existing tests, some things that have failed in the past from apps you may or may not have heard of, but I'll show you some examples, and then see some of the results. So the tool I worked on at AT&T is called Video Optimizer. It does apps and video. It's called Video Optimizer. And then on the web, there's a tool called Web Page Test, which is available to test web pages on all sorts of different devices. Both of these tools are free and open source, so they're really easy to get a hold of, use, because they don't cost you anything to do. Web Page Test is a service where you can do it two ways. You can either use the service as it is on the web, or you can download it and set up your own private instance. So if you wanted to test a website that wasn't public, you could do that as well. So when you want to test with Video Optimizer, it sees all the phones that are connected to your computer. In this case, it's a Samsung. You can change the speed of the network. And this is really important because when you live in a city where you have great 4G coverage, you get used to having really great 4G coverage and seeing stuff stream. But there are a lot of places in the world, even in Germany and in England and the United States especially, my house outside of Seattle, where I only get 3G. And so it's important to slow down your network speed to see what your app looks like or what your website looks like on 3G or even 2G. If your app is something that may be consumed in other parts of the world, like in Asia or in Africa, there's millions, if not hundreds of millions of people whose data is still just 2G. And it's important to see what that looks like. Facebook, they used to, I don't know if they still do, but their Wi-Fi would be turned down slow on Tuesdays, and they called it 2G Tuesdays. And so they got to see what their app looked like on 2G. I ran a bunch of tests about a year ago, and apps still work on 2G. They're really, really slow, but they will work, and it's pretty impressive. Streaming video doesn't work, but everything else pretty much actually works. So you can set the speed. We have a secure collector to kind of do a man in the middle, and then it also records the video on the screen, so you can see to correlate what was on the screen with what's being downloaded. You name the test, and then you go. And what you get is this is what shows up on your computer. It's just what's on the screen of your Android phone right here. I was looking at a real estate app. And what Video Optimizer does is it establishes a VPN. And the VPN is started on the device and terminated on the device. And because that VPN is there, we can siphon off all the packet captures and see all the data that's being transmitted. That's also why you have to be really careful about what VPN provider you use, because they can actually see all of that as well. But in this case, the VPN is actually terminated on the phone, and it just goes out over whatever network that you're actually using, whether it's cellular or Wi-Fi. So you can test your app. We're recording all of the data in the background. And then when you're done testing your app, we try to make it really simple. So you hit the red X to stop the collection, and it stops. The files are connected to your computer, so you can analyze it. What we do then is on your computer, typically when you have a network capture, you open it up in a tool like Wireshark. You guys use Wireshark to look at network traffic. Really complicated tool. There's a lot of power to it, but if you don't know how to use it, it can be really daunting. And I still find it daunting, and I've been using it for years. The goal here is make it really, really easy. If you've got a green check mark, that's good. And if you've got a red X, there's room for improvement. And so there's 40 best practices. I've kind of grouped them into different categories. And we'll talk about a few of them as we go through the talk tonight. If you want to do the same thing for the web, webpagetest.org, you pick the website you want to test. There are test locations all around the world, so you can see what your website looks like in Singapore, because they have devices set up in Singapore to test with, or all over the world. I do the ones in Virginia because they have lots of Android devices hooked up. I think he has 19 Moto G4s hooked up, so you can set up a whole bunch of tests all at once. You can test the Moto G4. And the Moto G4 is sort of like a sort of recent device, but sort of a mid-range. It's not like a super high-powered phone, but it's not a really low-end phone. It's kind of like right in the middle. So it's a good device to test on. And you can do all the same things. You can change the connection speed. You can do a whole bunch of tests with just one. You can capture video. And then there's like a gazillion options under all these tabs. So there's a million things you can do to test your website. And just go. And what do the results look like? Well, you get a bunch of grades up here in the upper right-hand corner. You can see page load time. So I built this web page. It's the summer vacation one that showed up accidentally. But I built it to be really slow. It takes 19 seconds to load, which is bad, right? And it's 11.2 kilobytes. It's 11.2 megabytes of data. It's really, really slow and really, really bloated. And so the idea was, let's see if I could make it fast. Build a really bloated website and then see what I could do to make it faster. But this is sort of the results you get, so that you can pinpoint where the issues are on your website if you want to do the same thing. So the first thing we can do is optimize the delivery of your content. And so as we've been talking, I live in Seattle, which is right here. And I ordered something from Vancouver, which is right there. And I was really excited because I knew this package was going to come super, super quickly, because they're only about 120 miles, which, I don't know, 200 kilometers? 200 kilometers apart. However, because of the vagaries of international borders, when you buy something and ship it FedEx and it crosses an international border, they all go to Memphis, Tennessee first, because that's where their hub is. So the package went from Vancouver to Memphis to Seattle. And obviously that's not super efficient for my package. Maybe it's super efficient from a grand scheme of like FedEx processing. But we see this actually with a lot of applications. Another Facebook story is their app in Indonesia was really, really slow. And they sent a bunch, they actually couldn't figure it out from their analytics data, so they sent someone to Indonesia to capture the logs. Volunteer, right? Can I go to Indonesia, please? To work. And what they discovered is they were using the wrong endpoints from their network. They were using a CDN from Bolivia. And so the traffic was literally going halfway around the world, if not more than halfway around the world, to these people in Indonesia. And so one of the best ways to do this is to use a CDN. So a CDN serves your content to the edge of the network. So even if you're here in Germany, your content could be in the Bay Area. And so it's delivered very, very quickly to people on the West Coast, rather than having to request it all the way across America, across the Atlantic Ocean. Have you guys heard of coinjacking? Or cryptojacking? So it's this thing that people are doing, and the biggest one is called CoinHive, and their server is actually in Germany. But what it is these people are injecting JavaScript into websites, and so when you hit the website, it starts mining cryptocurrency on your laptop or on your smartphone. And what it does is this JavaScript kicks up your CPU to like 100%, and it's like mining cryptocurrency and then sending the results back. So whoever has the keys making billions of a euro cents from you visiting the web page. And there have been a couple of really big attacks where it gets injected into some third-party code, and then it's on like 8,000 websites. And I was playing around with it, and you can make these pages, like the bottom of my laptop got too hot to have on my lap, right? I mean, it really heats up your computer a lot and drains the battery. And there was this big attack about 2 months ago, 8,000 websites for a full weekend. And the post-mortem was like, we believe the hackers made about $3 US. So it's like, there's not a lot of money to be made from it, but people are still doing it. I don't quite understand. But they only have one server. So if you ping it from Munich, it takes 10 milliseconds. But if you ping it from San Jose, it's 150 milliseconds. And Singapore, it's 200 milliseconds. So the speed of light is really, really fast, but it still takes a long time for this data to get around the Earth. And so here's my PowerPoint picture of San Jose to Germany, right? This can add to delay. It will make your app or your web page slower. And so what a content delivery network is the first request from San Jose goes all the way back to Germany, but then it's cached locally in San Francisco or Los Angeles. So subsequent hits of that same content is being served from a server nearby. So it's, instead of traveling halfway around the world, it's only traveling a couple hundred miles. You'll see that this company has CDNs where there's a lot of population of people use the internet. Africa, unfortunately, is pretty empty there, right? So they're still going to see some delays. You know, that's just the way they built it at this point. Another thing we can do is reduce the number of redirects. So maybe you've heard of this website, google.com. And so the first time you hit google.com, it does a 301 redirect to www.google.com. And then it does a 302 redirect to HTTPS version. So there's 2 redirects the first time you load it on a browser. Of course, this only happens the first time you hit Google, so it's sort of an artificial test because it happens once, and then since everybody uses Google a million times, it's way faster additional times. But the first time you hit it, the first content doesn't arrive until about 2.8 seconds. As we all know, 3 seconds, you lose a lot of your customers. It actually gets an F from web page test. And we can see it. Once content comes in, it loads really fast. It actually completely loads. You know, data comes in at 2.8 and it's done before 4 seconds. But there's this initial delay where we're watching it and nothing is happening. And then it loads. So once it starts getting the content, it's really, really fast. And I'm just going to move over because I keep hitting like the edge of that stairway, and that'd be really dramatic. I've only had one beer, but I've seen this in mobile apps. So there was a really popular music streaming app in America, and every single time it requested album art, it requested it to one place, it did a 302, and then sent it to a second place. And so in 5 minutes of testing, I saw 242 302 redirects inside the application. It added about 10% of a delay to the entire usage of the application. Every single page took about 10% longer to load because it was doing these redirects. And I was testing it because it was in the news. People were really excited about this new app. And I had coworkers coming to me and saying, have you noticed that it's slow? And I can tell you why it's slow. So this is a test from Video Optimizer. You see the red X, it failed. This app had a further problem in that they were screwing up the URLs on the redirect, and there were a lot of 404s. So they were doing a redirect, and then 33 of them actually, there was no file there anyway. So there are a lot of ways you can prove that, and so obviously making sure that the content actually works in your app or your website is a good thing to do. This app did another really very interesting thing that, how sometimes you have different sized images, small, medium, large, and I'll talk about that in a little bit. Rather than take the small image when they needed the small image or the large image when they needed the large image, they just always downloaded all 3, which really doesn't save any data. So they had a lot of optimization potential with their application. One thing that we also look at in our tool is we can see every request and response. Does anyone know what the HTTP response 418 is? I am a teapot. And it goes back to the days when people had cameras on the internet looking at coffee pots to see if there was coffee in the pot before you got up to go to the break room, you can make sure there was coffee there. And so it was an April Fool's joke. They said, I am a teapot. But what I love is PBS is public television in America, and there's some developer who's like, I'm going to make every picture have a I am a teapot response, which is kind of the ultimate in geek humor, because the only other person who sees that is someone like me who's looking at the HTTP logs in, looking at the network traffic. But I think that's really, when I see those, it always makes me laugh. It doesn't happen very often. The other thing we can do is optimize the delivery of our content. And so going back to the Amazon analogy, when you buy something from Amazon and you get the big box and it's like 90% air and bubbles, right? And then there's just one little thing in the corner. My kids ordered some pens once, and it was a box this big with like 18 feet of brown paper, and there's 2 pens in the bottom. That's not the most optimal way to deliver pens to somebody, because you just wasted a lot of space on the airplanes, the trucks, or whatever. And we see that with the content that's being delivered to mobile devices. And so, web page tests, you can test a single app. There's a tool called the HTTP archive, and every 2 weeks they look at 500,000 apps, 500,000 websites, and look at the content on those sites. And what we can see from that tool is that about 25% of all websites are text files, right? JavaScript, HTML, style sheets, whatever. 50% images, and 25% video. Now, every web page doesn't have video, but videos are so big that it screws up the averages across all websites. It's the Bill Gates walks into a bar analogy. So if we're all in here, we could calculate our average salary, but as soon as Bill Gates walks in here, our average salary is $150 million a year, because Bill Gates throws off the average by so much. So that's why video looks like it's so big. But let's look at how we can optimize text delivery. This is the video streaming app in America. And when you start it up, you log in, and then it downloads all the information about what TV shows, and it downloads images eventually pop in for each one of these TV shows, right? And that's all populated by this 130 kilobyte JSON file. And it has stuff like the name and the URL and all that sort of stuff. So you need that JSON file to fill this page up. But they're not compressing this file. It's 130, 131 kilobytes uncompressed. So it takes this long to download, which means it takes this much longer to get the images, the text, all that stuff onto the screen. But if they had just zipped it, it would be 16 kilobytes. If they used Brotli, which is another compression algorithm that's a little bit newer, it's from Google, it would be 12 kilobytes, which is just one round trip. Super fast, as opposed to maybe 5 or 10 round trips for the uncompressed file. You're going to get that content there faster. You can start downloading the image faster. The app appears faster just by compressing the text file. Obviously, saving 120 kilobytes isn't that big a deal, but it actually will accelerate the delivery of the other content, which is really important. Images. So images being half of the web and also really popular in mobile apps. So let's look at what we can do to make that run faster. Here is another movie app, right? And so I was reading about Frank Sinatra. And this is my phone, 2560 by 1440 pixels. And this image down in the bottom corner down here was downloaded, way larger than it needed to be downloaded. 1500 by 1200 pixels, and that's 1.5 megabytes. I don't know if you can see that. It's down over here, 1.5 megabytes. And I was on Wi-Fi, not a big deal, but if I was on 3G, that would have taken forever. So what can we do to make this image smaller? Well, we know the size of the screen. We could say, well, 720 wide, right? Let's just resize it. You can put it on your computer, resize it, and you save 76% of the weight, right? Just by resizing it. Oh, there it is. Sorry, I'm looking at the wrong part of my PowerPoint here. Sorry. So it goes down to 368 kilobytes. Another thing we can do is we can change the quality of the images. So JPEG images have a quality setting, and the lower the quality, kind of the less good it looks. You start seeing pixelation in the images. Google recommends at the very minimum, you make all of your images 85%. 85% will look good on any web page in any mobile app, and you get a little bit of savings. I'm pretty sure you can go lower on most images. I think 50% of images, you can stop right there. But I think for the other 50, you might even be higher, 75%, you can actually go to a lower compression, and the image still looks good to the average viewer. And so what does that look like? It looks exactly the same at 85% quality. But where's the difference? Well, if you look at the in the corner, that's what it looked like originally, and that's what it looks like at 85%. Right? So there's a difference, but it's so minuscule when it's only that big on, at the far corner, how big it is on the screen. So that gets us down to 550 kilobytes, but we can combine both of these optimizations, right? We can optimize both the number of pixels and the quality. One other thing about pixels, really, really quickly, is that on a low-end phone, when you download this image, if it's 1,500 pixels wide, the phone has to resize it. So you're almost being double taxed. You have to download the ginormous image, and the phone then has to throw away half or 2/3 or 90% of the pixels to show it on the screen. And on low-end phones, that means you're kicking up the CPU really high, the phone will get hot, and it'll take a long time. So almost the users are taxed doubly. They download a huge image, the phone then has to resize it, and then it shows up on the screen. So what if we do both? And what we find is the file is almost 90% smaller. And so obviously this is something you can do as part of any file being sent up to your server, right? You can do these optimizations, or you can do them by hand like I did here. There are also tools that will do it. So there's this tool called Cloudinary, and it's cloud-based and it has CDNs and does all the fast delivery stuff. But you set up the URL, and you just set a parameter, quality 85, and width 720. It takes the original image, and with just a couple, 50 to 100 milliseconds delay, it generates the custom image for you. And so, so there it is. You can do other things. I mentioned you can go to a lower quality. They do that automatically. So use Q Auto, and they run an algorithm that looks to see what the human eye would see as a difference. And it makes the image even smaller. We're at like 92% savings. And then the last thing that you can do that's really cool is you can make it automatically choose the right format. And so, of course, we're all Android here, and we all use Chrome. So WebP is a great, Chrome and Android support WebP images. And being that it was developed 4 or 5 years ago, it's a much more modern algorithm than JPEG, which came out in the 90s. So it gives you a lot more compression, and we're up to 95% smaller. That's going to get delivered a lot faster, and honestly, the users have no idea the image is different. So, why not? This seems pretty straightforward stuff. Another thing to talk about images is you may have heard of Twitter. So I did an analysis of profile pictures with Twitter, because Twitter's got to deliver billions of profile pictures to the web and to the apps that they have every single day, every hour. It's got to be a huge number. And what I discovered is 67% of them were not optimized for delivery to the end device, which is insane to me, because if you could optimize these images by 1 kilobyte and your Twitter, that would be a ginormous lift off of your back end, and it would also speed up the front of your apps. The other thing I discovered is that one of every 1,000 images of these little profile pictures can be as big as 550 kilobytes. So, and what I think it is it's metadata. So like when you save something in Photoshop, Photoshop puts all this text data that's never even seen by the end user, but it bloats the image so large, it actually makes it slower to deliver. So, I mean, I guess what I'm trying to say is this is hard, right? If companies like Twitter aren't doing it, it would be an easy win for them to do this. But it really does speed up the performance of your applications. Now, it gets difficult because one of the things I mentioned was, well, let's just resize it to be exactly the right size of the screen for my device. A guy at Akamai went to look to see how many Android devices connected to Akamai, which is the biggest CDN in the world, in one day, and that's how many Android devices connected to Akamai. Each box is a device. The size of the box is how many of those devices connected. So these are a bunch of, that's an S7, an S7, an S8, and right, newer devices. The color is how fast they are. So green means they're fast, newer devices. You know, red and orange are slower devices, lower end devices. And I believe there's 66 or 6,900 devices, Android devices that connected in one day. So obviously you can't build a different image for every single device because they're all different sizes. But what we can do is we can take an example from the web. And in the web, this is just the picture tag from the HTML. And for every width, you set a bunch of widths, you serve a different image. And these images are all about 25 kilobytes apart. So the most amount of data that you're wasting for any user is about 25 kilobytes, which is not great, but it's better than like half a megabyte that I was doing before, or whatever it was, 1 megabyte per user. And on the web, you can actually see what this looks like. Let's see if it lets me do it. Let's see if I can do this. This is the web page. How do we get that to go away? Maybe it'll go away on its own. It did. All right, awesome. So this is the same. This is the source that I was just showing you. And this is the web page. And so what I did, and I'll actually show you in the source here really quickly, every other image, I also made it sepia. So as I change the size of the screen, you'll see when a different image loads because one will be sepia and the other will be color. And so if I resize this web page, if I can find the corner. Oh, it's full screen, sorry. Let's make it, that's going to take away some of the fun, but. All right, so full screen is like that. As I shrink down the page, a new image shows up. And so you can see each one of these is 25 kilobytes difference. And so you see it creates a whole bunch of them and they just automatically load for the right size screen. And it only loads when the viewport is that size. So you don't waste all that data unless you're like me, you start flipping the page big and small. But you can see I've got like 15 images here. I can't click the corner, there it is. And a new image loads about every 25 kilobytes. So there's some pretty cool ways that you can optimize just by using 10 images. All right, it worked. We got back. The other thing for images is becoming really, really popular. Let me know if I have to speed up. Are we doing okay on time? All right. Is preview images, and you've probably seen this in a lot of apps and websites recently, where a box shows up instead of the image, and then the image pops in at a later time. And so here I'm in Google image search looking for cats in costume, because what else do you use Google image search for other than to look for pictures of cats, right? And you know, the color that it chooses sort of matches the eventual color of the costume of the cat in this case. And it makes, it lets people know that images are coming as they load into place. And so this is becoming a very popular thing to make applications load up a lot, just so people can see where images are. The other good thing about this is, like when you're reading an article on your phone and images pop in above and the text like starts bouncing around and you can't figure out where you're reading, this sort of solves that problem because the boxes are all there on page load, so you don't have to worry about the text moving around as you're reading an article. And so there's a tool out there called Squib, and it actually creates a vector image of each image. So this is in Croatian, this is a vector image of that same thing. So you can load that one first, and then that one pops in later. And what's great about vector images is that they're XML. And so you can zoom them any size, it doesn't matter. I mean, this is just blurry, not really very interesting. But it's 900 bytes, uncompressed. So then you can compress it even smaller and just put it inline into your code. It's not another request, it's just there really, really quickly. And I have a demo of that too, really, really quickly. Same. Yeah. This is and actually what I have to do is I have to slow down the network in Chrome DevTools for you to see them load into place. Right, so there are the images, and maybe I went too slow. But then the images pop into place. And you can see I coded this page really badly. I used the same image twice because I didn't do a good job. The other thing that I do here is, and I think I talk about this later, maybe I talk about it later, but I lazy load images. So these images down here aren't loaded, and they load in later as you scroll down. Because just like when you're using Facebook or something like that, they load stuff as you scroll so that the page loads the content only the content that you're actually consuming. So if I go down to the bottom of the page, these images haven't loaded yet, but they will load on a slow 3G connection. Let's speed it up. There they are. If I do it on a fast connection, you see them for a split second, right? You see those preview images for a split second. But what's great about, again, these images are super small. They're like 400 or 500 bytes, so they don't take up much data, so they don't hurt delivery of your content. If we move towards video, animated GIFs, everybody loves them, right? And so let's talk about what we can do to optimize the delivery of animated GIFs, because they're in almost every app that you see these days. And they're on the web a lot. And so I took this video of my goat. This is Nora the goat in Seattle. And there she is when I press play. You can see she's eating a cedar leaf. And this video is 1.4 megabytes. But we want this in all of its giffiness, right? We want this to be a GIF, 256 colors, because GIF is from the 80s. And that, 256 colors in the 80s, you're really happy. And here it is. If I click properly. No, I'm starting the movie again. Let's not do that. And there's the animated GIF, right? It's looping. It's doing everything that we want that animated GIF to do. But it's 270% larger than the original video. And the reason for that is GIFs is an image format, and it's actually like 35 images being flipped through at 15 frames a second. So video gives you compression on X and Y and then through time. GIFs don't give you that compression through time. So a video, this bit would never change because it's just the dirt and mud and the fence. So there's added compression when you do videos. So how do we make this animated GIF smaller or serve it as a video? Well, I can make it an MP4. I can make it 256 colors, and it goes down to like 250K. Right, and it plays, it looks like that, but I need to make it loop. So if you were building a web page, you'd use a video tag, you'd set it to autoplay. You have to add muted, because they do this for Safari and for Chrome, so that when you're in a meeting and you're browsing on your phone when you shouldn't be, and the video starts autoplaying, it isn't loud and people know that you're not paying attention. So all videos on mobile have to start muted, which is a good thing for all of us when we get caught in a meeting, playing video when we're not supposed to. If you're also doing this, you might as well strip out the audio track, right? If you're muting it anyway, you might as well strip out the audio track. Plays in line, you guys might not care about because that's an iOS thing. That's for Safari. And then you set it to loop, and then it loops. On web pages, video is the last thing to load. They always defer loading the video to the end because videos are big, and if it stops the images and the HTML and all that stuff from loading, it makes the page slower. So what they're actually doing now, in Safari, you can actually put videos in the picture tag. So you can actually load a video as an image, and it's fast. So here I'm loading the video, and then an animated WebP, and then the GIF And I really need to fix that box because I didn't make it look good in PowerPoint. And so what this is doing is, if it can play the video, it'll do that, and then it'll play the WebP if it can do that. WebPs are smaller than GIFs. And then the ultimate fallback is play the, 3.8 megabyte GIF file if we have to. There's an article about how you can do that in Safari now. Now the trick with this, of course, if you're building a web page and you do this and you put a 2-hour movie, it will autoplay on that web page. So you want to be careful about how you do that. And that sort of leads us into video and how we can optimize video on mobile. And video is much the same as anything else. If it's slow, people get mad. And so if it takes a long time for it to start up, or if it stalls, right? If you're watching a video and it stops, that's distracting to the end user and people get frustrated. And then of course, when people get frustrated, they throw their phones. So that's why I have a picture here. And so they've done studies on this. What happens when there's a delay to video startup? And basically you get 2 seconds. People will get any video, you get 2 seconds.